A gentleman had a problem with his wife. She thought he was a philanderer. And every day he would come home, she would check him and pick off every hair and lint. And one day he got really tired of this. So before going home, he took a lint brush and he made sure that he brushed himself so that she would have nothing to pick at. She gets more angry than she had ever been. What's wrong? What's wrong? He says. And she says, well, now you're running around with bald women. Well, of course, she had made the right observation, but came to the wrong conclusion. And science is all about making observations and coming to conclusions, and that's what we deal with through our office at McGill. We try to shine light into the dark crevices of the world of pseudoscience. We do this in many ways. We have a weekly newsletter that we distribute, and just by chance this week, we have something about toilet paper. Now, I wasn't aware of the CBD toilet paper, so we were only concerned about the direction of wiping. But we also organize an annual symposium, the Lorne Chartier Public Science Symposium. Lorne is a great philanthropist and a supporter of science. And over the years, of course, we've had all kinds of exciting guests speak. Randy was one of the first ones, and in recent years, we've had other deities speak to us. And as you heard, I do have a radio show. It's the longest running radio show on chemistry in the history of the world. It is also the only chemistry show. Anyway, let's get going here. You know, it was a dark and stormy night. And it really was. And there was a knock on my door. And I opened the door. Standing there was a salesman. He asked if he could come in. So say, by all means, had sorry feelings for him. He says, can we sit down in your kitchen? So we do. And he looks over at my water tap. And he says, is this what you drink? Well, I sheepishly said, yeah, not only do we drink this, we even give it to the dog. Seems to be okay. And then he has this frightened look on his face. And he says, do you know that there are chemicals in your water? Well, you know, I thought maybe it was a bit too early to say, boy, did you knock on the wrong door. Because I could sense something potentially delicious coming out of this. So I said, what do you mean? Do you mean the H2O molecules? No. I mean the invisible chemicals. So if invisible, how do you know they're there? He says, I can show you. He picks up his briefcase, digs in, takes out this apparatus, battery with a couple of electrodes, plunks it into the water, and says, watch. And of course, within a couple of seconds, you start to see this yellowish tinge, and the water becomes absolutely repulsive. Picks it up, has me look at this, and he says, this is what you were drinking. Well, of course, by now I had figured out exactly what was going on here. I knew that this was just iron hydroxide. I knew it was not coming from the water, it was coming from the electrode. But I still didn't know where was this going, so he digs up into his suitcase again, takes out a water filter, says, let me attach this. He passes the water through it, gets a clear glass of water, he puts the electrodes back into it, and of course, nothing happens. See, we've taken out these invisible chemicals. The message was that these frightening chemicals were hiding in the water until he had scared them out of solution by passing electric current through it. But of course, the filtered water no longer responds like that. So now it was time for a demonstration. So I said, look, let me put a couple of crystals of salt into this water. Now put your electrodes back in. And of course, the same thing happens. As you guys, of course, know, water does not conduct electricity unless it has some electrolytes in it. And when it does conduct electricity and you have an iron electrode, you'll get some iron hydroxide. Anyway, he looked kind of confused. And then I thought I needed a more potent demonstration. So I picked it up and I drank it because I knew I was only giving myself an iron supplement, but his face turned roughly that color. Couldn't believe anyone would do such a foolhardy thing. So I said, let me try to explain to you. Do you remember in high school, electrolysis. Did you ever study that? Of course, he had this blank expression on his face. So I said, look, we take this apparatus and we have water in there, we pass the current through it, and if one of those electrodes happens to be iron, we get iron hydroxide. It's not a big deal. Then I confused them further. I bought one of the filters because I was looking for something to take the chlorine taste out of the water. Of course, not because of this demo. Of course, he had just learned this spiel, and in his mind, it all made sense. Anyway, then I watched this confused man walk down the driveway out of my house. He opens the trunk of his car, puts his briefcase in there. Then he leans back against the car, digs into his pocket, and he lights up a smoke. So this guy, who was so worried about, poisons in the water, didn't understand that he was inhaling a whole collage of really toxic substances. Anyway, this is kind of funny. And there's nothing wrong with the filter. But look at this. This is an application of the same idea, a foot bath, $600 to $700. And this time, of course, they claim to cure various serious diseases. You put your feet in it, plug it in, and within a few minutes, the toxins have leached out of your body. You can see them. There they are. Of course, you get this intense color because there are obviously minerals on your feet with sweat, so the ionic content happens to be quite high. This, of course, is a completely different situation because here they're capitalizing on desperate people, and desperate people will do desperate things. But of course, this is not the only silliness. There are all kinds of other water silliness out there. For example, these carafes that you can buy, which have sacred geometry embedded in them because they are somehow designed with the golden ratio. You know what the golden ratio is? It's these dimensions that have miraculous properties, and they constitute wisdom. Anyway, these carafes are made by mouth-blown glass by these artisans in Europe. But why do you need these? Why do we have to buy this carafe? Because we have committed the crime of having our water circulate through straight pipes where they happen to hit angles, and then, of course, their geometry is totally destroyed. So we have to correct this by putting the water into these carafes. And then people will tell you that they drink from this and they feel so much better. How can people believe such stuff? Because they are ignorant of chemistry. Not only that, they think that chemists are these horrible people locked up in a laboratory just thinking about what new cancer-causing additive to unleash on an unsuspecting public. They think that we are a completely different species. And they read these books about the toxicity of everyday chemicals, and chemicals, of course, are brewed up by the devil. Well, the fact is that we do have some skeletons in our chemical closet. We have not always disposed of our chemicals in the proper way. Well, today, these skeletons include the perfluoro substances that you've heard so much about, the microplastics, which break down further into nanoplastics. There are some issues. However, we do have to remember that there are no good or bad chemicals. There are only safe or dangerous ways to use them. And I think that chemistry, of course, should be in the limelight, because it is the science that ties all the other sciences together. If you have a feel for what molecules are all about, what they can and cannot do, you have an idea for how the world works. For example, when we are confronted by people who are against genetically modified organisms, and of course there are many of these, they panic at the term. They think that these things, of course, are brewed up by unholy scientists in a laboratory. Now, you know, tomatoes are difficult to grow when you have a climate where you can have a potential freeze. But there may be a solution to this. because there is a protein that is produced by the Arctic flounder. And indeed, if you could somehow get that protein into a tomato, it would prevent it from freezing. And of course, there have been theories about this. This has been discussed in the scientific press. And the question is, what would happen if you managed to do this? If you really put this gene into a tomato, what would that tomato look like? Well, the cartoonists, of course, will have all kinds of ideas. But the fact is, the tomato would look like an ordinary tomato because of all the 30,000 odd genes in that fish. The one that you take out, which codes for one protein, is not what makes the fish into a fish. But in any case, despite all the discussion in the lay press, this never happened. It was never done. It was an interesting possibility. But the anti-GMO people still talk about this. No, there are no fish genes in tomatoes. But you know what? There are some pig genes in soybeans. A company called Moolec, Science and Alternative Proteins, has come up with a way to make a protein powder out of soybeans that have been genetically engineered to include some pig proteins. They don't make a big issue of this, and they don't try to hide it. They call these soybeans piggy soy. What's the idea here? The idea is to increase the protein content of the soy, because as we start to look towards feeding 10 billion people in the world, we're going to need more protein. Now, it's not clear exactly what gene they transplanted into the soybean, but it is probably a gene that codes for myoglobin, which is the reddish pigment that we have in meat. That's why the soybean looks pinkish. What's the motive here? Because we know that agriculture is not an environmentally friendly business. And this is clear. Whereas you can grow a lot of soybeans, not that there are no issues with that industry, but you can grow a lot of soybeans, produce protein, and when they have the added gene, you produce even more protein. And no, you are not going to become a pig if you eat this soybean. The soybean is going to taste totally normal. But of course, there will be all kinds of alarmists who are going to be screaming about this. Because that's what they do. They see a boogeyman behind every bush. There are boogeymen out there, but they're not behind every bush. But they will, find an issue and hype it all up. For example, they worry about our fry pans. Why? Because they can make your penis smaller. Now that causes me to pay attention to this study. So what are you talking about? A real study was actually done in Italy, and they looked at an area where there were a couple of factories that were producing these polyfluorinated compounds. And some of that, of course, gets into the environment. And they compared the penis length of some teenage boys to another group of such boys in a different area of Italy where there was no PFAS in the groundwater. And what did they find? They found a difference in length in the exposed group versus the control group. But if you look at those numbers and you look at the plus or minus, they overlap. I mean, basically, this is not a difference. Now, how they managed to actually get teenage boys to agree to this measurement, they don't discuss in the paper. But they're not the only ones who are worried about penis length. For example, if you're eating buffalo wings, this also becomes an issue, at least in the eyes of PETA, because they tell you that the chicken can be wrapped in PVC, polyvinyl chloride wrap. And that has a plasticizer in it, the phthalates. And they refer to some studies where they measured the phthalate content in the urine of pregnant women, and they see that it leads to smaller penis in the children to which they give birth. Once again, it is not statistically significant. These measurements are not easy to make. I don't think you need to worry about eating chicken wings because of the phthalate content. But let's not restrict our worries to men. There are feminine issues as well, as Gwyneth Paltrow is quick to tell us. And she, of course, looks at another part of the anatomy, in this case, the female part. And you do have to give her a little bit of credit for the way that she advertises this and the figures that she uses. But anyway, you're familiar with some of her ideas, certainly with the egg that you have to, Jade egg that you place in a part of the anatomy where such an egg does not need to be. But somehow it charges the body with energy. So what do you do when the egg becomes discharged? Well, you have to charge it. And you do this by placing it in the light of the full moon. Although in the instructions, they do not tell you that you should remove this from the body before trying to recharge it with the full moon. Of course, she's also into other things like the vaginal steaming, and this is not only steam, but you have to have the right herbs in there, and this, of course, will invigorate you and do all kinds of wonderful things to your hormones. The message here is, don't do this. This is not a smart thing to do. But Gwyneth also sells a whole range of other products, including these. Now, let me tell you, I've been in this business now for well over 45 years. And I never thought that I would be standing in front of a crowd like this talking about sex toys. But I do this because there actually was a study about the consequences of using these. Why should anyone study this? Well, here the statistics are real, because this is not an unusual thing. There are many people who use these items. The market is huge, as you can see, predicted to reach $50 billion by 2025. So some of you are using this, no question. And there was a huge spike in this during COVID. People just needed more entertainment. So what did they do in this study? They actually subjected these devices to a machine that abrades the surface so that they could measure what was coming off. When you rub this thing, as of course happens when you're using this, what is happening? Well, it turns out that you get some microplastics coming off of this. And when you do a chemical analysis, they contain the phthalates. And sometimes in doses that are higher than what is acceptable. Now, why are they in there? These phthalates are plasticizers. They make the plastic soft and pliable, which is good for these devices. But this is not the only place you find such plasticizers. You'll find them in your shower curtain, your PVC shower curtain. And there's the issue here too, because these are endocrine disruptors. And the alarmists will tell you that if you're using one of these PVC shower curtains, you're taking your life into putting it in someone else's hands. But the fact is that we are surrounded by endocrine disruptors. They are everywhere, not only in synthetics, but also in the natural world. Soybeans contain isoflavones, which are endocrine disruptors. And of course, they are often recommended therapeutically to women who are coming into menopause. They do better with soybeans. When you are drinking that glass of red wine, you're getting resveratrol. Resveratrol is an endocrine disruptor. Of course, they never talk about that when they talk about the supposed benefits of red wine consumption, which actually are not scientifically justified. ethanol, of course, is a known carcinogen. So anyway, you're getting endocrine disruptors when you're drinking red wine. So people say, all right, forget about that red wine. Let's go back to drinking the tap water that we started our story with. Well, you may want to store that tap water in plastic bottles. I mean, we see people running around all the time, clutching these bottles of water, sipping from them constantly, as if you stop that for a couple of minutes, you turn into a prune. No, you don't need to be sipping the water all the time. There's no scientific justification for the 8 glasses of water every day either. You drink when you're thirsty. Anyway, at the University of Copenhagen, they studied these bottles and what happens when you put water into them. Well, I'm sure most of you are familiar with Locard's principle, which basically says that when 2 substances are in contact, you will always have some transfer of substance from one to the other. No question about that. So when you put water into plastic bottles, something will happen. Now, the bottles that they studied were not the polycarbonate bottles. Polycarbonate, of course, is somewhat worrisome because it will release small amounts of bisphenol A. And that is certainly an endocrine disruptor, and it has other complexities that come along with it as baggage. So anyway, they did some very sophisticated studies on this and published a paper. And I must say that I was surprised by the results of this study. Of course, I talked about this a lot. We've done experiments in our lab about what leaches out, but I never expected the large numbers that they found. Most of these come from the detergent in the dishwashing machine. We're talking about thousands of compounds that leach out that can now be detected. So that bottled water that you fill from your tap, and if you've stored it in there for hours, as most people do, there will be thousands of compounds, including a number that are endocrine disruptors. But what do we make of this? In science, as you well know, numbers matter. We're always comparing numbers. We're always thinking in terms of numbers. The question is how much? It's trace amounts. Today, we can measure parts per trillion. That's the width of a credit card in the distance between the Earth and the Moon. That's impressive. I tell my analytical chemist colleagues that they are the root of our problems, because they're not finding that needle in a haystack. They're finding that needle in a world full of haystacks. So if you know there's one needle in one haystack somewhere in the world, is that going to restrict you from a good old-fashioned roll in the hay? Probably not, because you would figure out that the benefits outweigh the risks. And the thing is that life, in fact, is full of risks. We have to live with that. You can be out for a casual walk, and terrible things can happen. Oh, don't go, we're nice people, we faked it. They're fine. But they're not the innocent creatures you think that they are. But the trouble with risk is the way that people perceive it. If it is a risk that they've decided to take on their own, they don't worry about it. But if they think that it is a risk that is imposed on them, that's a different story. Chemicals in your water, even though they may be there in parts per trillion, that's a real problem because you did not decide that they should be there. Of course, as we know, everything comes down to a risk-benefit analysis. And we better be sure that when we replace one substance by another, that we're not going from the frying pan into the fire. That if we find a substitute for bisphenol A, we better make sure that that is the right thing to do. Now, of course, there are some risks in life that can be mitigated. We can do something about it. You can decide to avoid that risk. But indeed, there are some risks that no matter what you do, you cannot avoid. But I want to leave you with a few ideas that I think are useful, especially when we try to get this across to students as they are embarking on a career. The presence of a chemical cannot be equated to the presence of risk. Just because we find something doesn't mean it's doing something. That takes a lot more investigation. On the other hand, just because something is present in trace amounts, that does not necessarily absolve it from guilt either, because there are some substances that are horribly toxic in small amounts. If you think of botulinum or ricin from castor beans, these are toxic in nanogram amounts. And that's comparable to the amount of hormones that we naturally produce anyway. So, these things may matter. But their ancestry does not matter. It doesn't matter if a chemical was made by a chemist in a lab or by Mother Nature in a plant. What matters is what its molecular structure is, how much we have studied it, and what we know about it, not where it came from. There are a couple of other things we have to remember. We have to remember that children are not small adults, and that something that may be perfectly safe in an adult is not safe in an infant when the nervous system is just developing. And then, of course, humans are not giant rats, with some exceptions, obviously. But animal studies are not always a good model for humans, but on the other hand, we usually cannot do the requisite human studies for ethical reasons. And no matter what, we can never say that there's no risk associated with a chemical. Maybe someone living in the backwoods of Siberia reacts to some chemicals that we don't. So we always have to make sure that we transmit the information correctly, that we make educated guesses about risks, but we can never be totally conclusive. And there are diverse opinions on virtually every subject, but it doesn't mean that they are equally valid. Yes, when you look at climate change or you look at vaccination, you will have people saying that these are totally nonsense, that climate change isn't happening, that we shouldn't be vaccinated. And sometimes these outliers make a very good argument. You have to give them some begrudging credit. They speak very well. And if you don't know the science, it sounds very convincing. But of course, what we look for is consensus among experts. And when you look at vaccination, look at climate change, there's no doubt where the consensus is, as you well know. But unfortunately, any position can be supported by cherry-picking data. And that's what the quacks, charlatans, and the alternative practitioners are very adept at doing. But one of the most important things that we have to point out, and we have to do this constantly, because the young people are not aware of this, that correlation is not the same as causation. And just because you can draw a graph showing that glyphosate, Roundup sales have increased parallel to increase in autism, doesn't mean that they are connected. Because obviously you can also draw a graph linking autism to the sales of organic foods. And that is not likely to be a cause and effect relationship. So anyway, I like to leave students and audiences with these kind of ideas, and I usually summarize them with words from one of my heroes. Happens to be Sherlock Holmes. Why? Because of a classic statement. And this is one that is well worth remembering. It's a capital mistake to theorize before one has data, because one insensibly then tries to form the data around the theories, of course, instead of the other way around. And in science, we always have to make observations and try to come to the right conclusions. And as you've seen from some of my pictures, I do like to surround myself with ducks. And there is actually a reason for this. When I started to get into criticizing quacks and quackery, I got into the habit of collecting ducks. Of course, my family thinks I'm nuts, and there may be something to that. But at first, I collected a few, just, representative of quackery. And then I decided that it might be a good idea to surround myself with these, to be constantly reminded of the need to fight. Because we are now in a situation where science is at the risk of being overrun by a tsunami of quackery. And we have to keep pointing out how we know, what peer-reviewed science is all about, and that chemicals are not to be feared, they're not to be worshipped, they are to be understood. And I think you will agree that with all of what is happening and what we've heard from many of the speakers here, it is more important today to be able to separate sense from nonsense than it ever has been. And that is what we try to do. We have this weekly newsletter, and if you go to our webpage, you can sign up for that. Obviously, it's free. And I also do produce every week a couple of very short videos, 3-4 minutes. If you want to be involved in looking at those, you can just send me an email, and I'll put you on the list. And I try to deal with topical issues and try to get the message out of the importance of separating sense from nonsense. And I hope that with what I've done here today, I've been able to maybe unravel some of the mysteries of chemistry for you. Thank you.
Joe Schwarcz, everybody. Thank you so much.